Meta recently released their state-of-the-art models, Llama 3.2. These come in various varieties. There is the base model, which is 3.2. There is the 3.2 Instruct, which has been fine-tuned. And then there is the multimodal version of these models. In addition to releasing these models, they also released the infrastructure needed to spin up inference servers using these models. And they call this Llama Stack. And this really makes the development of software using these models much easier. Now, since this infrastructure is relatively new, there are a few gotchas that I had to struggle through to get it working. And in this video, I'm going to do a walkthrough of how to set up the Llama Stack for inference, and hopefully this is going to save you guys some time. We will start with an empty project in Visual Studio Code. And you can see this is the new directory that I created. And on the right, you can see the documentation for Llama Stack, and you can get to it relatively easily by searching Llama Stack in Google, and it'll take you directly to the documentation. The first thing to note is that even though you might be seeing a Mac over here, this is me tunneling into my Ubuntu machine. And you really need a machine with a GPU in it, an NVIDIA GPU in it, in order to be able to make this work. If you try to run it on Mac, you will realize that the Mac silicon is not supported up until relatively late in the process. And what really breaks is that there is an FBGem library that is getting used for doing computations, and that is the stack is unable to install that library. And the other big favor that you can do for yourself is start with the Conda environment manager. If you start with virtual environment or pip, you will end up with a fair bit of trouble. It essentially will have issues during the build phase of the project. So you can save yourself a ton of time if you start with the Conda environment manager. And there's an option to use Docker as well, but I haven't explored that too much. In fact, there is a version of this video that I tried to record with a virtual environment created using venv, which didn't quite work. And so you'll hear references to that learning through the video when I said, well, when we tried this earlier. But I think you're best served by just starting off with a clean slate with a Conda environment manager. All right, great. So you can see that I have the Llama 3.2 Conda environment created, and I have also activated that environment. Now, for my next steps, what I need to do is I need to build the Llama Stack, but for good measure, I need to first install the Llama Stack within this virtual environment as well. So this is going to run through the entire installation process that you saw with the virtual environment earlier. And the learning there is that you will be able to make this stack work with Conda, but it seems that right now you can't make it work with just venv. All right, next steps are to build the Llama Stack, and for that you just use their build command and go through the usual process. I think what we had said was we're going to use the 11 billion parameter model, so we'll just kind of give it a very descriptive name, and you want the image to be in Conda, and then you take Meta's default reference design for all the other things like the inference API, safety API, agents API, and so on. And now this should basically create the build without any hitch. So there are a few other build options that you can see over here, and once the build is complete, it's going to write the configuration into a YAML file, which it'll store within the .llama directory in your home folder. Having built the model, now you have to configure it, and the Llama Stack gives you a helpful command to be able to do that. So we're just going to cut and paste this and hit enter, and it'll take you through a bunch of different options for this. The first thing that you want to do is tell it what was the model that you want to use, and we used the 11 billion parameter model which was multimodal, so had both instruct and vision in it. This is the model that we downloaded in the earlier step. Oh, I think I got that name wrong. All right, vision and instruct, not the other way around. Okay, then do you want to use quantization? And if you have enough of GPU memory, you can go with a full-fledged model, but I would typically say, yes, you do want to quantize. And I typically go with mixed precision quantization. But this is the amazing thing about the stack, that basically you can get the model, you can get the base model, and you can run it as is. Or if you decide, well, this is taking too long, or it is taking too much memory and I would like to go with bigger batch sizes for inference or what have you, you can just rerun this configuration and you can use the quantized model as easily. And then you can experiment with that, and you can really try to figure out what works best for your use case in terms of the precision versus speed versus memory footprint. I'm going to go with the default seed. I'm going to go with the default max sequence length. Let's say batch size is 1. Do you want to configure Llama-Guard and Shield? Not right now. Prompt-Guard Shield? Not right now. And then it gives you a bunch of different options for persistence, and I'll go with the default. We'll use SQLite. It's going to store this KV cache in SQLite, and this is the database path, and accept the defaults, and then you're good to go. And then all that you need to do is run this, and I'm going to run it locally on the port 5001, and it will list out the bunch of APIs that are or the endpoints that are available to you. All right, so we're going to now start the server, and in that we're going to use the previous command that you saw, which is Llama Stack run, and then the name of the stack that you created. Additionally, what I'm going to do is disable IPv6 features so that you're able to actually connect to the endpoints that are being served. So just hit enter. It's going to take a moment to start the UVCon server, and it's going to show up on port 5000. And at this point, if I were you, I'm essentially going to localhost on 5000 and then trying to hit the endpoint / health check, which if everything is working, it'll show you an OK. And you can see this over here. Now, I'm not going to be able to do this for the video because the machine on which I'm actually running this is a separate machine. And so we're going to do something which is maybe a little bit more fun, and it'll show you the capabilities of this model. So I just created an IPython notebook, and if you go into Llama Stack /docs, they provide you a bunch of getting started notebooks that you can use. And what you want to do is you want to import the client library like so. All right, so a bunch of installation, and then you're going to tell it what the local host is and what is the port number. We're going to use the same model. And then, just because we can, we're going to get Llama to write a haiku for us. All right, our Python kernel is still getting installed. It's taking a moment. All right, this didn't quite work because we needed to install the Llama Stack client as well. So let me do that. Right, let's see, this should work now. It should work now. And then look at that. I mean, that was so quick. I've taken the raw models and tried to run them directly without using the stack, and it is much slower for smaller models. So there is a bunch of optimization that I'm sure that has gone on under the hood. I don't know the details. Those are some things that I would like to discover down the road. Let's see if we can use the multimodal version of the model. So here I have downloaded a picture of a dog playing frisbee, and we are basically turning it into a URL that the model can understand. And then instead of writing a haiku, I'm just going to ask explain to me what's going on in this image. And let's see what it says. The image depicts a dog running through grassy fields with a frisbee in its mouth. The dog appears to be a golden retriever characterized by its golden coat and floppy ears. It's running towards the camera with its front leg. I mean, there is just incredible amount of detail in this. I mean, yes, sure, you can get them to get the model to write haikus about dogs on skateboards, and that's fun. But imagine the kind of use cases that you can unlock with this level of detail and this level of fidelity from a multimodal model. So super interested in learning what people build with this. Reach out if you have any interesting ideas that you want to discuss on that, and I'll definitely be taking it for a spin on a bunch of different data sets that I have in mind. All the best.